Okay. Antennas and towers. If you're installing an antenna, you need to make sure that you're not close to a power line. In fact, they recommend that when you install an antenna or a tower, that in the case that it might fall over, no part of it should be closer than 10 feet to the power line.
Right.
If you got a lot of property, that's nice. Where I am, I'm afraid my vertical antenna would be across the power line if it ever fell.
That's not good.
Which is why I have 3 guy wires on the side opposite the power line.
Mhm. Keep it from going that way. Okay.
You should never put an antenna up on a power utility pole because there's high voltage power lines there. Plus, the utility company wouldn't let you anyway. When you do have a antenna up and you're transmitting, places on that antenna can have extremely high voltages, and you can get what's called an RF burn.
Mhm.
Like I said, they supposedly are very painful. So you should also try to locate the antenna where somebody that doesn't know what it is can't just reach up and touch it. So which of the following is an important safety precaution to observe when putting up an antenna tower?
Charlie.
Charlie.
What is the minimum safe distance from a power line to allow when installing an antenna?
Delta.
Yes, Delta.
Why should you avoid attaching an antenna to a power pole?
Charlie.
Charlie.
What hazard is created by touching an antenna during a transmission?
Bravo. Radiation poisoning.
Bravo.
You're not going to get electrocuted, and you're not going to get radiation poisoning because okay, if you put up a tower, you need to make sure that you have sufficient training on tower climbing. Now, the Melbourne Club, Clyde gives a tower climbing class several times a year. So if you had any interest in climbing a tower, you can go attend that class and actually learn how to do it, or just what to do as a ground crew where you don't really want to climb it, and kind of get certified. If you are climbing, you need to make sure that you are appropriately tied off at all times. Usually that means that, well, you definitely need a climbing harness, one that's approved. And you need a can't think of the word right now, kind of a safety rope or wire that you can connect. You always want to do it above your head, so in case you fall, you're not swinging upside down.
Yeah.
You should never climb without at least a helper or observer. You need at least somebody who can call 911. If it's a crank-up tower as opposed to a fixed one, where it's in sections, and you either manually or have an electric motor that raises the sections. Those sections will have some kind of interlock to lock them in place. You need to make sure that those safety locks are in place if you try to climb up a crank-up tower. If it's a tower that has guy wires, there will be turnbuckles to tension those guy wires. And you need to make sure that they have safety wire on them so they can't work their way loose from, because you actually get a lot of vibration from the wind.
Mm-hmm. Mm-hmm.
Here's a couple examples.
Oh yeah.
Actually, these are both crank-up towers. That's a fairly nice one there on the left. And fortunately, I don't see any power lines close by, so he's good.
I see upper
That's
houses
not-
though.
Huh?
I see upper houses though.
Yeah.
I would be, if I were that upper house, I'd be thinking about it. What happens if he forgets to crank it down? Crash. Is that real?
yeah.
Take it down during a storm, that's for sure.
And it could fall
Yeah.
over on the house next door. That wouldn't be good.
Or your
Or your
house,
own
but then it's your fault.
The one on the right is just another view of a crank-up tower. You can see the sections.
Mm-hmm.
There's a typical approved safety harness, and the lanyard or whatever it's called, so that you can tie yourself off. And that it's not really a carabiner, but that loop,
Similar.
metal loop there attaches. There should be a loop on the back of that harness that you can attach that to. And then you've got these two others that you can put up on the tower or on the ladder. You probably should use it climbing a high ladder also. So what is required when climbing an antenna tower?
Delta.
Yep.
Under what circumstances is it safe to climb a tower without a helper or observer?
Never.
Delta.
Which of the following is an important safety rule to remember when using a crank-up tower?
Charlie.
Yeah. Charlie.
What's the purpose of the safety wire through a turnbuckle used to tension guy lines?
Bravo.
Okay, towers should be grounded.
Yep. Otherwise, you just have a giant lightning rod.
Well, it's still a lightning rod.
Yeah, but it doesn't necessarily
Yeah, I was
go into your house instead of into the ground.
So most of these amateur towers tend to be triangular. So you have three legs.
Right.
You should have an 8-foot ground rod close to each leg and all of them tied together. And then that should be connected over to your ground system.
Mm-hmm. Should it be the same like what you do with all your equipment?
Yes.
Okay.
Ideally, like in the commercial installations where they really get serious about lightning protection, you have what's called a perimeter ground, and your entire house or building has ground rods and ground wires all tied together around the perimeter, as well as the lightning rods that they put on the roof connected into
Right.
that. So it's kind of like a big.
Doesn't that make you kind of like I hate to ask this, but doesn't that attract lightning more?
Well, yes and no. Um, it can uh, discharge the charge somewhat to
Hmm.
prevent a lightning strike.
Okay.
But also, if there is one, uh, it's going to send the current to ground,
Hmm.
assuming that you have used, big enough wires and cabling.
Hmm.
And you want to get it to ground as quick as possible
Right.
before it gets into your house.
Right. Well, with Tampa being the lightning capital of the world, pretty much, and we're not far behind.
Yeah. Most of Florida is.
Yep.
Mm.
The last few thunderstorms we've had, it's like you hear it walking as it's coming towards you, you know? You hear this
Yep.
boom, 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 and then it's on top of you and it's all around. I'm just waiting for the rest of the trees to die out so I can see how many of them got hit.
Uh, uh, you need to make all of your connections as short as possible.
Hmm.
Try not to put right angle bends, have smooth curves, because
Right.
any sharp bend is actually
It could be a discharge
increasing
point.
the inductance, so that can encode current flow. Uh, and like you
Is
mentioned
reduced
before,
opposition the same thing as a discharge point, or is it just kind of like a stopper?
I missed the first part. What was that?
So if you have a sharp bend in any kind of wire like that, does it just impede the current from passing along, or
Yes.
is it also a discharge point?
No, it would try to oppose it. So a quick lightning burst when it got to that um, sharp bend, it would initially look like an open circuit, so it wouldn't be conducting it, and it would allow the voltage to increase uh, to the
Kind of
point
like a
where it would be
dam,
arc
like a
over to
water dam. Yeah, yeah. Mm.
the other thing is all the connections not only make them short and direct, they should all be mechanical compression type connections. You don't use solder joints in uh, ground wiring,
Mm-mm.
because if you did have a lightning strike,
You could blow
the
the solder.
thousands of amps of current would vaporize the solder
Hmm.
instantly, and you would no longer have a connection. Which of the following establishes grounding requirements uh, for an amateur radio tower or antenna?
Bravo.
What about the rules?
I say bravo.
I say, oh, but I'm wrong. Why would it
In
just
this
be
case,
local electrical codes? I mean, isn't it universal anyway?
well, the way standards and codes work
Hmm.
is the international or the federal is there. You can have state or country codes that comply with the international but are more restrictive.
Hmm.
Then you get down to where you can have city or local, which
Yeah.
still have to comply with the higher up, but they can be even more restrictive. So the local electrical code is going to be the most restrictive on your grounding requirement.
Gotcha.
So you go around building an antenna, I bet you need a building permit.
It depends on your local code, and it's my understanding If it's below 50 feet, you don't need a permit in this area where I am. If it gets higher than that, then you have to have a permit and some drawings and things of it, kind of like an engineering submittal.
Mm-hmm.
The other restriction is with the FAA, which limits how high you can go, depending on how close you are to an airport.
Right.
Right, definitely, yeah.
Oh,
That's
well,
okay. I was going to
We
answer
knew
that one
that.
anyway.
We were cool with that one.
Yep.
Which of the following is good practice when installing ground wires on a tower for lightning protection?
Bravo, of course.
Probably. Right. We all got that joke.
Yep.
Charlie. Charlie is the answer.
Which of the following is true when installing grounding conductors used for lightning protection?
Charlie.
Charlie.
We really get this sharp bend thing.
Yeah.
And actually, it's not easy to do without having some bends too. What should be done to all external ground rods or earth connections?
Well,
I don't think we covered this, so let's just figure it out.
bond them together with heavy wire conductive strap. Keep them forward. What should be done to all external? They should be bonded together.
Right.
Okay.
Because from there, then you go to your, what do you call it? Other ground, equipment ground. But I kind of like Delta is pretty cute.
Well,
Getting
you
a little
can.
desperate there, are we, for choice?
Yeah, really. Or the silicone caulk and electrical tape, that ought to do it.
The only thing that would do is keep them from turning green.
Yeah.
Yeah,
For a
but it's
while.
from a common sense point of view. You think, well, maybe it should be like that. It wouldn't be good if they rusted or something.
Well, that's what I do. No.
Okay. Lightning.
Yep.
It can come down the feed line,
Mhm.
even if it's not a direct strike. It could be close enough that it could induce current in the feed line from your antenna back into your station.
Yeah.
So one of the things you can do to prevent that is put in a lightning arrestor.
Is that what Duke is trying to sell everybody here? Here's one of these what is it? It's like they're trying to sell everybody these grounding boxes to protect all the equipment in your house. For an additional $9.99 a month plus tax and all the other
okay.
things.
Yeah, I don't know what those actually are, but they make lightning arresters for coaxial cable.
Mm-hmm.
And they're also, some of them are designed for specific frequency bands and also different power levels. So if you go get a cheap one off of Amazon, it's probably going to be limited to HF frequencies and 100 watts. To get one that is capable of handling the maximum power, which is 1500 watts, you need to pay a little more money. The way most of them work is they have a gas discharge tube that's connected between the center conductor and the ground, the shell of the lightning arrestor.
Mm-hmm.
And those will conduct current when they get up to a certain voltage. So the voltage is set for something higher then your operating voltage, like in the case of if you're doing 100 watts into a 50 ohm antenna, you'll see about 70 volts RMS. So usually a lightning arrestor that is good for that 100 watt range is got something like a 90 volt gas discharge tube in it. And these can take multiple discharges, although there is a life to them. They'll only work so long, and then you have to replace the tube, and usually it's a little screw-in plug that holds it in place. I actually had to replace one here a month or two ago, and they're around $10 to $15 a piece. So you want to install these lightning arrestors in your feed line outside of your station, preferably at the entrance panel where you come into the station, where it's grounded. The other thing that you can do, which they don't talk about, is at different points, you can run your feed line through a coupler that has a ground lug on it. So it allows you to ground the shield at various points along the way. So if you had high current on the shield due from a lightning strike, it would allow you to send that to ground before it got close to where your shop was. Let's see. Yeah, this is kind of a little block diagram of the gas discharge tube inside the lightning arrestor. They may or may not have a DC blocking capacitor, which is also something else you need to look for. Because if you were trying to, say, operate an antenna where you had a low noise amplifier mounted up on the antenna, usually you power those up through a DC voltage on the feed line, which you can't do if it's got a blocking capacitor in it. And then the other one is kind of very simple block diagram of what a radio would have. And there may or may not be a static bleed off resistor, because you don't have to have a lightning strike. You can have a charge build up on the antenna just from the wind blowing across the antennas, especially if there's moist air. And it can actually build up a big static charge. So it's helpful to have that bleed resistor, which will give that voltage a path to ground. And it's a high enough value, it's not going to affect your signal. So where should a lightning arrestor be installed in a coaxial feed line?
Delta?
Oh, I'll take Bravo. Oh, well, never mind.
Yeah, usually you're going to have some kind of, you typically would bring something in through a window opening. And they actually, you can make them, or they sell panels to fit different size windows that have feed-through connectors already installed.
Oh, nice, yeah.
Or in some cases, people drill holes in the wall and run it through the wall.
I have a coaxial feed of some kind or other from before I owned this house,
I
and
got a couple of mine.
don't really know exactly where they begin or end because they have no function anymore. But it used to be where the TV
Mm-hmm.
Yeah.
connected.
Yep.
I suppose you could reuse those if they were, I mean, are there any coax as coax?
No, that's probably
No?
for cable TV,
Yep.
Yeah.
and it would be 75 ohm, and also low power cable. It would handle 100 watts, but not much more than that.
Uh-huh. Okay.
Okay, so we talked about installing antennas and towers. Make sure you're not close to power lines. They want you to make sure that you're not within 10 feet if it falls down.
Mm-hmm.
Obviously, you don't put an antenna on a power utility pole. Uh, Mount your antenna such that it's not easy for somebody to make physical contact while you're operating. Uh, you need to have training to safely climb an antenna tower using the appropriate harness and tie-offs. Never do it alone. Never climb a crank-up tower unless the interlocks are in place. And always make sure that your turnbuckles on the guy wires are safety wired, and you need to check them. The other thing that's not on here, in some cases, there may be actual electrical power on that tower.
Mm-hmm.
Like in the case of really tall towers, there's a flashing light on the top for aircraft.
Yep.
And things like that. It could be even equipment like a repeater or something mounted up there. You need to make sure that the power is off when you climb a tower. You need to make sure that all 3 legs or 4 legs are grounded, tied together, tied to the rest of your grounding system, using heavy wire or strap, and as short and direct as possible. And always use lightning arresters on your feed lines as close to the entrance to your shack as you can.
Mm-hmm.